Welcome to Module 2, Part 2. So here we will be discussing about the broad vision of the semantic web and the technology stack that powers the semantic web. And basically, that is to say, we'll be discussing the architecture of the semantic web. So to start with, let us take a motivating case, basically a use case that will be useful to derive a set of requirements for the semantic web. So this is a hypothetical situation where Jane is a working lady working in, let's say, in one organization in a city in some country, right? And Jane, being a working lady, she has to go to the office, and needless to say that there is a stipulated office hour, and Jane needs to perform some medical examinations that are suggested by her consulting gynecologist. Now, Jane has an agent, so you can see the agent here. So the agent, it works for Jane to help her out in different aspects. Now, Jane puts forward the requirement to the agent. What the agent does, it talks to the agent of the gynecologist to see what are the examinations that have been prescribed by the gynecologist. Right. Now, taking that list, Jane's agent looks or forwards this query or search to the agent of the insurance organization on which Jane has done or subscribed to any insurance, medical insurance. Right. Now, what the agent of Jane asks to the agent of the insurance organization is that what are the medical centers that are covered under this insurance organization, right? And of course, Jane's agent is always looking to find the medical centers that are closer to either Jane's home or Jane's workplace, right? Now, after getting all the list of the medical centers that are covered under insurance, Jane's agent then asks the agent of the independent rating agencies to see whether they are good or not, right? Now, these independent rating agencies, what they do, they provide rating to the medical centers based on certain parameters, right? And of course, for these rating agencies, there is an agent which is really catering to the need of the other human or other user, right, or other agents, right? Now, after getting the rating from the independent rating agency, what Jane's agent does, it looks for the available appointments from the agents of the medical center, right? Now, after getting those appointments, then it looks at the calendar of the Jane to see whether there is any free time, right? Now, Jane's agent finds two solutions or two appointments really. So, one solution says that the test can be done, but it will be available in 2 weeks. The appointment is available in weeks. But for that, for Jane, that is too late. So, other option is that there is another appointment for another, maybe another medical center. But for that, Jane has to stay in the city center for 3 hours after the work. So, it is also not going to work for Jane, right? Now, Jane's agent then goes for another search, right? Like in this scenario, what Jane's agent is doing, it is not really looking at the medical centers that are completely covered under the insurance, but it also looks for the medical centers that are independent of this insurance. So they might not be covered under insurance. Now, getting that list from, of course, another agent, it looks it asks the agent of the insurance organization to see whether the medical centers that are independent, how much of their costs are covered under the insurance, right? Now, with this information, the agent again asks the independent rating agency to see how good or bad these medical centers are. Now, with all this information, uh, uh, it finds out a set of solutions or medical centers, and for them it is looking for the available appointments by talking to the agent of the respective medical centers, and also it is asking for how much cost it will incur, right? Now it can find a solution, and again of course looking at Jane's calendar. So the solution has got a catch, like Jane will be late for 1 hour and the appointment is for tomorrow, but Jane will be late for 1 hour, and the medical center, it charges a little more than what is covered under insurance by the insurance organization. Now, with all this, it communicates to Jane that it has found a better solution. Now, Jane asks for explanation, like how do you know that it is good, or why do I have to go later tomorrow at work, or will you inform my boss? So there are certain explanation, also instruction. These are being forwarded from Jane to the agent, right? Now, agent has got all the answer because the agent has done all these procedures. It has accumulated the information related to all this, and it has performed a set of inferences or reasoning to come up with the solution, right? And it provides the explanation to Jane, and Jane is happy to see that that Jane has to pay only a few extra pound, and then Jane asks the agent to make all the arrangements after she receives the explanation, right? So first, what Jane's agent does, it marks the schedule of Jane's calendar, informs the boss, agent of the boss, and books the medical center through the agent of the medical center, right? Now you can see that here the human, here Jane is not really going to the individual websites like the medical centers, the doctors, or other stakeholders. It is the Jane is delegating the task to the agent, her agent, right? And what is her agent doing? Her agent is talking to the other agents of the respective stakeholders to gather information from the individual agents and performing set of reasoning to come up with the solution or the answer uh, to accomplish the task given by Jane, right? So this is the kind of use case that was thought to be realizable if the semantic web architecture is implemented in a full-fledged manner. So this is a kind of vision that semantic web started with. So let us try to generalize this vision. And to generalize this, we need to see what we need to have in order to support these use cases, right? So, if you see that the individual stakeholders or the organizations like these medical centers, the insurance organizations, the independent rating agencies, they provide data through their agents to the other agents. So, the individual organizations, they need to publish their data. They share their data, and as it is being shared, they can be reused by the other agents over the semantic web. Now, while someone is publishing the data and expecting that this data would be understandable by the other stakeholders, other agents, they cannot follow individual schema or internal schema. The data should be published, and of course, data should be represented in an abstract data structure so that it is understandable by the other agents, right? And if that is achieved, then the agents, they could talk to each other with a shared understanding. They have a shared understanding about the state of the world or the knowledge about the world, and if that is so, then they can perform automated inference by gathering data from different places. So what are the core requirements then? One can publish data, one can represent the data in an abstract form, there should be a common language through which these agents or the programs will be able to talk, and then there should be a support for reasoning, right? So I can say these are the broad requirements to realize the semantic web. So if we talk about this vision or the requirements, so how do we, or what kind of infrastructure should we have to have these requirements implemented, right? So needless to say that as these framework or these data sets or the communication, they are being used by different agents from different organizations, the software components, they should be generic. The languages in which the agents communicate with each other, they should be generic, and the protocol by which the data is transferred from one place to another, like one agent is querying the other agent and the other agent is providing answer to those queries back to the queried agent. So for all these, you have to have a set of uh, commonly understood protocols. Like, so if we have these three, at least these three components implemented in a generic framework, then there would be seamless interaction between the agents, right? So to make the requirements more concrete, so let us see what are the kind of policies that the traditional web, the current web, they have taken to realize what it is now, right? So why we're trying to do that? Because we have seen that web or www is a very successful project by the human being or the total global community, and it is growing in a very rapid rate from its birth. And if we can follow the same footsteps, then we can also realize the dream of having semantic web. So that is point one. And the point two is, if we follow similar kind of framework, then we can reuse certain things or certain components that are already there implemented in form of web. So basically, these two are the motivation uh, behind discussing why this web architecture has become successful, or web has been successful by following a certain set of policies, right? So the first policy is that you let people do many things on the web, right? So the first thing one can do, one can just easily set up a web server and connect that web server to the internet, right? So there are many people who can do that, right? So for example, IT Kharagpur admin, they have set up a web server and connected to that outer internet, right? And then there are more people than people who can create web servers. They can create documents, put the documents online, and link one document with the other, right? So you can think about the faculty member, the staff, the students. They can create web pages and host those web pages in the web server of IT Kharagpur. And you can see that the admin team, it is only one, but the people who can publish the documents, these are many, right? And there are even more people who can browse or access the web documents that have been published by through a web server in the internet, right? So you can think of the global community, whoever is accessing IT Kharagpur web page, they are the third category of people we are talking about. So you can see that there is a clearly distinct pyramidal structure connecting the web server, the people who can create web servers, people who can create document, and people who can access these documents, right? So the second point, or the second strategy which made web successful or prolific, is that it allows graceful degradation of the user experience. So what do you mean by that? So let's say you have a page in IT Kharagpur, right? Or your some due to certain reason, the IT Kharagpur website or the web server, it goes down, right? And it is disconnected from the other part of the network. Still, the other part of the internet, it will be working more or less fine. You will not be able to access the pages of IT Kharagpur, but it will work. The other part will work perfectly. In many cases, the hyperlinks that are given, they can be broken, but uh, mm, it really doesn't matter to the wider community whether a single hyperlink is broken or not, because there is a lot of redundancy of information over the internet, right? Some part of the network can be slow, but again, it does not really affect the other part of the internet uh, mm, in that way, right? So the third strategy that is worth mentioning is the quality of output is not really at the control of any central coordinator. You don't have any central coordinator who is looking after the quality of each of the documents while before they are being published on the internet. So this is not the case. So I have an idea, I can create an HTML page, put that idea in that page, and just link that or publish that on the internet. That's easy, right? So the users can easily create and access documents over the internet without any central coordinator or moderator who is checking the quality, right? So you know that, okay, well, we can have junk contents, possibly harmful contents, but there are many more other contents out there that are of good quality, right? So the concern about the quality is separated from each other. So you have documents of varying qualities. Now, let us try to see what are the kind of envisaged characteristics of the semantic web, or what are the kind of characteristics that we want to see in the semantic web, and try to see what are the kind of parallel constructs in the web, right? So the first thing that we need to have is a very simple and explicit data representation, right? So this is what we want in the first place. So this will facilitate many things, like it will be motivating people to add more content over the semantic web, add more data on the semantic web, and the user, they should be oblivious about the underlying technology. So they should not be worried about or concerned about what is the underlying technology in which the data is being published and data is being transferred to the other part of the world, right? So the web parallel of this is basically you can write documents in HTML form, which is a very simple tree structure data representation, and which is very simple to write, right? You just need to write HTML tag open, body tag open, you write something, body tag close, and then HTML tag close. You have a HTML document. The next characteristic that we want to have, that we want our semantic web to be a distributed system where anybody having some data can publish that data over the semantic web without any central control, right? And the ownership will be distributed, right? So if we have this distributed ownership, it will facilitate the scalability of the semantic web. So this is basically a similar thing we are doing with respect to the web. So in the web, we can create the websites and the web pages without any central control, and these web pages and the websites, they are under the full control of the content developer or the producers, right? So you can see that we have written some letters after each characteristic. So R stands for explicit simple data representation. D stands for distributed system. So we will use this later while we discuss more detail what would be our concrete requirements. The third characteristics that we want to have in semantic web is the ability to cross-referencing, right? So if you have a data item, in the data item you have a description about an entity, you can cross-link that description with the descriptions about the entity in the other, or related description about the entity in other data sources, right? So in short, we'll be able to cross-link one part of the data in one data source to another part of the data in another data source. And the web parallel of this is basically is the hyperlink that you can create from one document to the other document, right? So the fourth characteristics that we want to have is that we have to have a loosely coupled implementation, right? So here we want to have a communication that is facilitated by a set of standardized languages, right? And even now, if you have the standardized languages, so it might so happen that for an organization, this particular language is not sufficient and they want to put something more element while they are describing their resources in this standardized language. So we should facilitate them to customize the description, or the customize the language, and with the expectation that this will not really affect the overall communication, right? So this is what we call as loose coupling. And the web parallel of this basically again HTML document. So if you have certain recommendations put forward by the organization like W3C. So this W3C is one important organization as far as the internet is concerned. So they work on all the protocols. So they standardize all the protocols, all the languages related to the World Wide Web, and so they have provided certain recommended standards for HTML, but the developers, they can customize it more by adding more elements to it, but the overall communication will not be affected, right? And finally, I think the most important thing is that the publishing and consuming data should be very easy. Otherwise, the semantic web will not be participated in a greater way, as we see the same thing in the traditional web, right? So it will be easy to publish and consume both simple and complex data, right? And the web parallel of this is basically the HTML language. You can write very simple constructs, and these, if you write something in this HTML language, they can be viewed, managed, and composed using the softwares like browsers, right? So these are the five broad characteristics that we want to have uh, in semantic web. So the first thing is simple and easy representation, R. The second is distributed system. The third one is ability to cross referencing. Fourth one is loose coupling, and fifth one is ease of publishing, right? Now, coming to concrete requirement, so the first thing that we need to have, we need to represent the entities to say that and to add to that more the description of the entities and their relationship with the other entities in a very simple language. So that, of course, we are talking about a representation. So the R part of the characteristics, emphasized characteristics, will be coming into picture. So we can describe a person, say the birthday of a person, or the name of a person. So these all we should be able to do. Now we talked about the agents. So what the agents are doing, they are exchanging data between each other, among each other, right? So basically you can think of these agents to be the computing node, and they have data with them, and they want to exchange this data with each other to solve certain problem. It may be complex or simple. Now the representation that we have talked about is an abstract representation. I guess by now you guessed rightly that this abstract representation is a graph-based representation, right? So you have an entity, you have a set of relations or properties that you want to describe about the entities, and this is linking another entity, then you are linking another entity from this entity as well. So it is coming out to be a graph, right? Now this graph is the abstract representation that we are talking about. Now this, you cannot really transfer this abstract representation directly. So for that you have to make it grounded, and this grounding process is called serialization, right? So this serialization should also be done in a standardized manner. Otherwise, the serialization what you have done, that might not be understood by other agents in the on the semantic web, right? So you can think of the serialization to be, say, you are transforming a graph, to, say, a file, right? So basically you are writing that which node connects to which node, and you have a list of such connections, and you are storing that in a file and transferring this file from one node to another node, right? Of course, it is something to do with the representation, because you have the graph in picture, distributed system because you are talking about exchange of data in different computing node, and loosely coupled because you have a language, the standardized protocol by which you are translating this graph into a serializable form, and that requires a language. Now this language should be standardized, but one can add more on top of that, right, or customize them. So this will facilitate ease of joining information from different places, like these are three very huge data sets over the semantic web. So you can add one entity from music brands to another entity in Wikidata, or one from Wikidata to another from DBpedia. The third requirement is that the entities, they must be referable from one data set to the other data set. Basically, this is the point of cross-linking that we have talked about, right? So you have got multiple owners. You have got, say, one. So you have, say, 5 or 6 owners. You have got different data items over here. So what you can link this item to this, or this item to this, so and so forth, right? So again, it is addressing the representation part. It is addressing the distributed system part, cross-linking part, as well as the language part, right? So to give you an example, you have the description of Nick Mason in Pink Floyd data set, and or a data set about Pink Floyd stored in some server, and then from this server you might want to link this Nick Mason to the Nick Mason that is found over, say, Facebook, right? Now the language in the first place, it should be expressive because we want to describe any topic or anything about any topic in the world. So it should be expressive enough, and on top of that, it should be written in a language so that it is understood by machines or interpreted by machines. And again, we are talking about representation, loose coupledness, and ease of consumption and uh, mm, production or publishing, right? So again, it will. So why do we need this machine understandable? Because of many reasons. So we started talking about this from the first class. But also it has got many other benefits if it is machine readable. Now, if you see this cross-linking, if you do it manually, it is really hard to achieve, right? So why don't we have an automated way of linking? So for example, say Lionel Messi described in Wikipedia with say Barcelona FC, which is described in Wikidata, right? So these are all we need to have. So finally, you have data sets. You can cross-link data set from one data set to the other data set. Now, we need to put forward what query to this data set and retrieve the result or aggregate the data from different places or results out of different data sets to find out the answer to my query, right? And it is as we are talking about access or consumption of data in the with the help of the query, it is coming under the easiness of publishing or consuming data, right? So we can ask certain complex queries like the novels of Amitabh Ghosh that have been translated in French. So you see this is a bit complex query that we are asking to the system. Finally, we are doing, or you can go back to the use case. You can see that the agent, Jane's agent, there it is collecting data from different places and performing certain reasoning tasks to come up with the solution to the task given by Jane, right? So it can be very simple or it can be very complex, right? So it relates. So for example, we can have a rule like this. So someone's nationality that can be related to someone's country of birth, right? So these are the kind of rules we can write, and then looking at the nationality, the country of birth of one person, we can infer the nationality of that person. So the inference can be this simple, or it might be more complex. Now, the other important point is that you need to transport data and query from one end to other end. So, you have got two clients. So, for example, the Jane's agent and the medical center agent. So, what Jane's agent is doing, it is creating a query and targeting that query to the agent of the medical center. And in response to that, the agent of the medical center is coming up with a set of answers, and these answers are being delivered back to the Jane's agent, right? Now, this has to be done again in a standard protocol, and this protocol is already there, the hypertext transfer protocol, which is basically the protocol of www, right? Now, in some cases, you want to have a secure communication. So, you want to encrypt your query or encrypt your data so that the other party, they will not be able to see whatever you're requesting and whatever you're receiving. So, in that case, you want to have something like secure HTTP protocol or HTTPS in short. There are some additional requirements that we need to have. So, for example, we need to have different ways to interact with this huge data set, or in summary, the semantic web. Now, as we see that for the case of the web of documents, we can view a document, we can search for a document, we can browse Similarly, we can view, search, browse or query the data as we can do in the web of documents. And in many cases, we want to have data integration on the fly involving multiple sources, right? So while we talk about publishing data over the internet, the ownership of the data becomes very important. So for example, I am a rating agency. So there are multiple rating agencies out there. Now, I have published my rating about, say, some movies, or some other agencies. They have published their ratings about the same set of movies. Now, as a third party application, it depends on how do you trust the ownership or the owner of a data, and depending on that trust, you want to use the data of the owner which your application is more is trusting, right? So this ownership in technical term is called provenance. Who is holding the data, right? Who has the authorship of the data, right? Now there are different strategies or algorithms by which the web pages in the documents, they are assigned with trust values. Now we have to think about how do we assign trust on data items. So this can be a completely different problem than the problems that are on the trust related problems on the web of documents, right? But the other question that was not really relevant in the web of document but becomes very relevant in web of data is, while you are aggregating data from different places, who has got the ownership? So you have got multiple sources from which you are retrieving data, you are getting data, and you want to present an aggregated data. So as you are aggregating data from multiple places, the question of trust, it becomes a bit difficult, right? So these are kind of problems or challenges that are really important to semantic web, and researchers are working on these set of problems. Basically, trust is a very important problem in semantic web. Now, you have multiple data sets, and as these data, they are being produced in a distributed way, you can have uh, different or same data, same entity description in different places, though these data sets, they may cover different aspects of the entity. Now, it would be better if you can find alignment from one data item to the other data item. It can be easily done if the URIs are matching or the identifier of the data items are matching exactly, or we can use some other intelligent techniques to align this unconnected data set. But this is another very important requirement to realize this web of data. And if we do this automatic alignments, then only web of data would be scaling up in an organic manner. So with all these requirements, let me present to you the semantic web architecture, which is basically also called the semantic web stack or a layer cake, right? So you can see that this architecture looks like a cake having different layers, right? So we'll be discussing all these layers one by one in this in the second part of this of this semantic web vision and architecture. But to give you a broad overview, so let me start with the lowest level. So as we were talking about earlier, that every data item, they should be identifiable. So you need to have identifier, and as identifiers, semantic web makes use of the uniform resource identifier to be the identifier of the data items. Now you need to uh, you need to present certain value or the description about the resources. Now, this description can be done in multiple languages, like it can be done in English, it can be done in Hindi, it can be done in Bengali, it can be done in French, any language, right? So, this to facilitate this, Semantic Web makes use of Unicode, and I guess Unicode is also the standard for the internet. Now, to have to realize the serialization or data exchange between the different agents, we need to have a language through which we can represent data and transfer this data or transport this data from one place to another place, from one agent to another agent. So, this is basically taking care of the serialization aspect, right? Now, as we mentioned earlier that multiple data sources, they might be having their own internal schema, right? Now, we need to elevate that into an abstract representation. And this abstract representation is basically this RDF or Resource Description Framework. Resource Description Framework. So, this is basically an abstract representation based on graph-based representation, and this basically maps the internal representation to an abstract representation, right? Now, in order to perform inferences or reasoning over this data, we need to have some common structuring of this data, right? So, for example, there are many entities that are described on the semantic web. For example, say A.R. Rahman or uh, Pandit Ravi Shankar. So, there are many entities on the semantic web, right? Now, I can say that all these entities are instances of, say, musicians, right? And we can say also that the musicians, they are subclasses of person, and from that I can infer Pandit Ravi Shankar is a person, right? So this is, I think, the simplest inference that we can do, right? But if we just restrict ourselves into these set of constructs like subclass of or similar to those, we cannot really express the complex information in the world. So we will talk about this complex information. We have an example in the next class itself, next part of this lecture itself. So this complex representation, they can be achieved by something called web ontology language, or in short OWL. So with OWL, we can represent complex representation or complex relationship between the concepts of interest in a domain, right? And not only this OWL and RDFS, on top of that, we need to have something called rules. The rules are basically they are important component of any reasoning system. So we have got set of rules and set of facts that are known to your current world. So, for example, I can have a rule like if rainy, if cloudy, then it may rain. Now we say that today is cloudy. So from this I can infer that today it will rain, right? So this is the rule that I am talking about, and this is a fact that is assumed to be true in the current state of the world, and from this I can infer this new fact, right? So we see that rules are important, and these rules are represented via rule interchange format or semantic web rule language. So to represent this rule, we need to have a language. Now with all of this, we have the data, and on top of the data we have got the organization. So this is the data part, and put together all this. These are organization of the data. And in order to query the semantic web, we can query both the organization and the data. And this query language for semantic web is the SPARQL query language, right? And on top of this, we need to have a system or algorithm that will be able to align multiple data sources. So the example that we have given earlier, that you have a description of Lionel Messi, say in the data set published by Argentinian football team, and you have another data set published in by say Barcelona FC club, and there you have got also mention about Lionel Messi. So if you have a logic to align these two, you can connect the data, different piece of data or different data sets together with very simple means. So this particular logic layer is called the unifying logic layer. And also we have seen that the agents, they have been asked to provide explanation, right? So they have been asked by Jen. So the Jen's agent was asked by Jen to provide explanation about why the agent found some solution to be good, right? So for that we need to provide the trail of reasoning to the uh, person or the being who has asked for a solution, right? And of course, on top of everything, you need to consider the trust of using a data, right? Who is holding the data, and if someone is holding the data, how trustworthy is that? So is it like if a data source has been used by multiple other applications, this data source is trustworthy? So this can be thought of like recursive definition of trust. So some data source has been trusted by many, and this data source has trusted other data sources. Like so the trust value can be accumulated from one part of the network to the other part of the network, right? So there are different ways we can think about this trust assignment to the uh, data sources, right? And all these layers, they also consider encrypting the data while this data is being communicated from one end to the other end, and that belongs to the domain of cryptography. So you have a layer of the cryptography as well. And finally, you have the layer where you have the user interface and different applications that are using the data down here by traversing the layers that are there down, right? So let us stop for now. In the next part of this video, this lecture, we will be taking each of these layers and try to see what kind of protocols, what kind of languages or frameworks that are there to implement this architecture, right? So in the next part of this video, we will summarize this entire layer cake and providing some examples to get started with. Thank you.